Hello everyone, welcome to Electron Configuration. This video will serve as just a way for people who are catching up, people who are just not understanding about this concept, or people who are just reviewing for the upcoming Unit 2 summative. This is how I personally do it, and I know that Mr. Barry, has very demurely given us this long, like, string of sublevels and orbitals to remember, and that's cool. And he's also like taught us, how to do noble gas configuration by just looking at the periodic table, like looking at the numbers, which is cool. But I'll be honest, like I'm not used to that, and I don't really want to learn it. So yeah, I'm just gonna show you guys how I do electron configuration. Now, in old chemistry literature, you'll probably find this diagram, or something that looks like this. Now, don't fret, because it's actually pretty simpler. Is that even a word? Who cares? Anyway, so instead of remembering this long string of, orbitals and letters, what I like to do is I like to, just use this diagram. And first, I'd recommend you just construct this diagram in your notebook really quickly. All right. So how we do this is basically we fill the 1s subshell first, 2s, 2p, 3s, 3p, 4s, and then 3d, and then we start going down this way and then going up and go down this way. Please note, and this is a common mistake, is that like when you're going to 3D, and let's say you have enough electrons to fill 5s, right? You would first go to 4p first and then to 5s. You don't go from straight to 5s. Yeah, just because 4p is just a lower energy level than 5s. That's just how it works. And then up here, 4D, and then after you fill 5s, you go to 4D, 5p, 6s, and then go up here, and then go down again, and go up, and then go down again. Okay, so instead of just showing you this, I'm just gonna demonstrate it, live, I guess. Let's do strontium, 38. So let me just write that down. 38. First it starts filling 2. And this is 10, 12, 18, 20, 30, and now we're going down this route. So 36 and 38. Which, yeah, and then you would write out this whole thing as your electron configuration. If you want to do noble gas configuration, you would do, oh, we should probably not erase this, my bad. You would probably just do, you would find the noble gas with the closest amount of protons. Xenon's not available because, it's 54 and has more, and krypton's close. Yep, okay, good. So I would do krypton and Kr, and since we can summarize 36 electrons, so we just get rid of those 36. We're left with 2, because 38 minus 36. So you would just put krypton 5s2. All right, let's go. Let's do another example. Maybe a harder one. Okay. Let's do Nd, which is neodymium. Yeah. Oh, that's the thing in magnets. Okay. I didn't realize the name of that. Okay, anyway. Let's start filling again. So 2, 4, 10, 12, and then 18 down here, 20 up here again, 30, 36, 38, 48, 54, oh my god, 56, and then this one you would just only fill in 4 because you only have 60 for that neutral atom. And yeah, this would be the whole entire electron configuration. And for noble gas, let's find the one with the closest amount of protons. So let's do xenon. Xe, because xenon has 54. This one's too big. Okay, so we should be left with 6 electrons outside of that noble gas. So 6 electrons. Oh, I guess to kind of backtrack. So so it'd be 6s2 4f4. Yeah, or just let me just rewrite that real quick. So it'd be xe, and you put 6. You would put 4f first. My bad. 4f first, because the numerical value, and then 6s last, and you would have 4p4 6s2, and look, it follows that exact order. It's nice. Yeah, and feel free to go try it out on your own. I just taught To Me by Khan Academy, the GOAT. I'll put in a link of just a molar, no, not molar, it's an Electron Configuration quiz by chemquiz.net, and you should be good. See ya.